Well, welcome back to our flipped classroom. Tonight's topic is called the zero product law. So let's get this definition in our notebook. The zero product law says, if the product of multiple factors is equal to zero, then at least one of the factors must be equal to zero. So what is that saying? Well, if A times B is equal to zero, the only way for this to be true is either A equals 0 or B equals 0. The only way I can multiply two terms together and get 0 is one of them must be equal to 0. And that's all the zero product law is saying. So we can immediately put this law to use. The first set of directions say solve each of the following for x. Now you'll notice that in number 1, it's already factored for you. Okay, they weren't given the original equation, but I factored it and said my factors are x plus 7 and x minus 3. So what that means is one of these, at least one of these, has to equal 0. They certainly both can, but at least one. So you might have heard the firm tee it up in between the two factors, and basically you're making a t between them, and you're setting each side equal to 0. So x plus 7 equals 0, and x minus 3 equals 0. And then I'll go ahead and solve, subtract 7, so x equals negative 7, add 3, and x equals 3. Now, one little hint, you'll notice there were two x's, so I should get two answers. Let's try another one. Number 2. X times the quantity 2x minus 5 times x minus 6 equals 0. Now in this case, notice how many x's you have. You have 3, so you should be getting 3 answers. So this one's kind of like a double t. I'm going to tee it up between those two factors and between these two factors. So on this side, I'm just saying x equals 0. Here I'm saying 2x minus 5 equals 0. And here I'm saying x minus 6 equals 0. Well, x minus 0, there's one answer. I'm going to solve this. I'm going to add 5. So 2x equals 5. X equals 5 halves. There's a second solution. And add my 6 over. X equals 6. So I have 3 solutions. And I could have anticipated that because I had 3 x's in the problem. Number 3, can you anticipate how many solutions you're going to have? Hopefully you're not getting tricked and you're only saying 2. You'll notice there are only 2 x's in the problem. But watch how we tee it up anyway. So again, I'm going to tee it up in between the factors. On the left side, I'm going to say 4 equals 0, 5x minus 6 equals 0, and 3x minus 8 equals 0. Now you'll notice this, when some people fall for this, there is no x here. There is actually nothing to solve for. And does 4 equals 0 even make any sense? No. So that's not a solution. I can only solve when I have an x. So here I'm going to add the 6 and divide by 5. I get x equals 6 fifths. And here add the 8, divide by 3, x equals 8 thirds. So please don't fall for this. If there's not an x, there is no solution. I have 2 x's, 2 solutions. So very rarely is the problem going to be solved for you and you're just going to tee it up. Most likely you'll see an equation that looks like this. So we've got x squared plus 3x minus 14 equals negative 2x plus 10. And our goal is to solve. Okay, and that's the key word here. We have to actually solve for x. So the idea is you always want to set one side equal to 0. So maybe make a note for yourself. Set one side equal to 0. And that's your goal. So I'm going to add the 2x over to both sides and subtract the 10. So I end up with x squared plus 5x minus 24 equals 0. Okay, and since I'm solving, I'm going to factor and tee it up. So let's see. Multiply, add, multiply. Got to multiply to 24, add to 5. So I'm going to say that's x plus 8 and x minus 3, tee it up, equals 0. Remember, set both of these equal, so x plus 8 equals 0 and x minus 3 equals 0. When I solve, I'm going to get x equals negative 8 and x equals 3. I would say I have 2 solutions. Let's go ahead and try a second problem. 3x squared plus 12x minus 7 equals x squared plus 3x minus 2. So go ahead, pause it, at least do the first step on your own, set it equal to 0, we can compare equations. Do we have the same equation, and does yours say equals 0 at the end? Just double check that. Now we've got a factor. Now, we've got that fun guess and check factoring again, multiply, add, multiply. But this one's actually nice because you only have one option for 2. It's got to be 2 and 1. And you only have one option for 5. It's got to be 5 and 1. So I think I'm going to go with a 1 and a 5 here. And how do I know if I'm right? Well, we simply put the boxes around the outers and the inners. Here I get 10x, here I get a 1x. I can certainly get a 9 if I add the 10, make that a positive, and make the 1 a negative. Now I want to keep that equals 0 on the end, and now I have to still t it up. So I'm just going to drop my t down a little bit. 2x minus 1 has to equal 0, and x plus 5 has to equal 0. So I get x equals 1/2, and x equals negative 5. So again, two solutions, and I certainly could have anticipated that because I have two x's. The next section says, consider the system shown below consisting of a line and a parabola. So hopefully you're aware this is the parabola by now. It has the squared term in it, and this is our line, or linear, has nothing squared, just y equals mx plus b. The first set of directions say find the intersection points algebraically. Okay, so basically if I were to graph these two functions, they would intersect, and now we just have to find it algebraically instead of graphically. Well, you'll notice this equation is equal to y, and this equation is equal to y. Therefore, if they both equal y, they must be equal to each other. So I'm going to set these two functions equal to each other. Again, it's just a simple substitution. You could also think of it, you're plugging the 4x plus 5 into this letter y. So again, I want to set it equal to 0. So I've got 3x squared, subtract the 4x, it's minus 12x, subtract the 5, those cancel, and I get equals 0. Now what type of factoring is this? Well, I only have two terms, so I'm going to start by looking for a GCF. Notice it's not that multiply, add, multiply, you only have two terms. I'm going to pull out my 3x, and I'm left with x minus 4 equals 0. Tee it up. And again, anticipate how many solutions should you get? How many x's do you see? Hopefully you're saying you should get two solutions because there are two x's. Setting each side equal to 0. Here I get x equals 0 divided by 3, and 0 divided by anybody is just 0. And here I should get x equals 4. Now let's go back and see if we answered the question. It says find the intersection points algebraically. At the moment, you don't have points. You only have x values. A point consists of an x and a y. So what is this telling me? Well, it's telling me it intersects twice. One when there's an x value of 0, and one when there's an x value of 4. Since I know x, I just have to go get y. So if x is 0, how do you get y? Well, you go back to your original equation, and you can choose either one, whichever one the math looks easier on is the one I would pick, and substitute in your x value. Well, we just said x is 0. So if I take my nice simple linear equation and I plug 0 into x, I'm going to get 4 times 0, which is 0, plus 5. So when x is 0, y is equal to 5. And I'm going to do the same thing and substitute in the number 4. When x is 4, I'll go back to my equation, y equals 4 times 4 is 16, plus 5, I would say 21. So these are the 2 points the parabola and the line should intersect. The next set of directions says using your calculator, sketch the system. So how are we going to sketch the system? Well, in y1, we're going to put our first equation. In y2, we're going to put our second equation. So our first equation was 3x squared minus 8x plus 5. And our second was 4x plus 5. So pause it, go find that calculator, and let's get this typed in y1 and y2. So after I have these in y1 and y2, I'm hitting zoom 6. That is my standard window, and you'll notice it says the word standard. We've talked about that before. And when I hit that, hopefully yours is doing the same thing. This is what my function looks like. Now we just proved that this line and parabola should intersect twice. However, on my screen, I can only see it intersecting once. Here's my parabola, here's my line, bam, I intersect there, and it looks like it's going to happen again someplace up here. So what you need to do is you need to get a better window. Since I'm assuming it's going to intersect someplace up here, that would be my y-axis that I'm going to change, and up here would be my y-max. So pause it, come up with something so you can see the whole function on your screen. Alright, I found myself a better viewing window, and like I said, hopefully you've done the same. Now we're going to verify the intersections using our calculator and using a special tool on the calculator called the intersection tool. So to get this intersection tool, you're going to hit the following buttons, and I suggest you write them down so you can remember them. We're going to hit second and then trace. Okay, and we've used second trace before to find mins and maxes, and now we're going to use it and choose number 5, which says intersect. So again, make a note for yourself. You're hitting second, trace, and obviously, choosing number 5, intersect. Okay, when you do that, and hopefully you're following along with your calculator so you won't be lost tomorrow, here's what it should say. In the bottom left, it's going to ask you a question. It's going to say first curve. Now, if you look at the top left, it would say Y1. Do you agree 1 stands for first curve? If you agree, you just hit enter. When you do that, it should now say another question in the left-hand corner, second curve. And you'll notice the top magically jump to Y2. Do you agree 2 means second curve? If so, hit enter. Then they're going to ask you to randomly take a guess. You actually don't need to move the cursor. If you want to guess and move the cursor to the intersection point, good for you, but you don't have to. Basically hit enter, and it will tell you what the intersection is. So you don't actually get an intersection until you see the word intersection on your screen. Now, does anything feel off to you? We said when we did it by hand, we got the 0.05. Well, sometimes on the graphing calculator, based on our pixel error, it puts it in scientific notation. Does common sense tell you that if you're on the y-axis here that your x value should be 0? I hope so. And you'll notice this number really isn't 1.5. It says 1.528 e to the negative 14. Well, e is scientific notation on our calculator for 10, and it's basically saying move this decimal 14 places to the left. If I add in 13 zeros, would you agree that's pretty darn close to 0? So again, this is just a pixel error on our calculator, and be very careful looking for that e in there. It is clearly a 0 when I'm on the y-axis. So I do get the 0.05. Now it doesn't give you both intersection points at the same time. You have to go through the whole process again to go get this point. So I'm going to walk you through it one last time and show you one little trick. And hopefully you're, again, playing along with me here. So hit that second trace button and choose intersect. Now here's the only trick. Before you agree that it says Y1 or first curve in the bottom, you have to move your cursor closer to this point. Otherwise, it just keeps giving you the same answer over and over and over. It'll keep telling you this point. So before you hit enter at all, move your cursor closer to this intersection. And then hit enter to agree with Y1, enter to agree with Y2, and enter to guess. And it should tell you the next point was the same coordinates that we had gotten. So let's get this in our notebooks as well. The zero product law helps us find the zeros or the x-intercepts. So here is one nice looking parabola. Let's do this. Let's identify the zeros. So in your notebook, let's go zeros, and let's say what x equals. X equals at this 0, -1, and x equals at this 0, 3. Now here's what you can do. Since you know the zeros, you can actually write the equation of this parabola. All we're going to do is work backwards. So picture what we did. We had a quadratic, x squared plus something. We factored it, we teed it up, and we got x equals blank and x equals blank. Now let's go backwards. Let's say, okay, x equals -1 and x equals 3. Go backwards. What would the previous line look like? What would this line look like if you got x equals -1? It would be what times what? I would say x plus 1. And this would be x minus 3. Would you agree with that? Equals 0? Think about it. If I solve for x, I would subtract 1 and say x equals -1. And if I solve for x here, I would add 3 to both sides and say x equals 3. Now that I have my factors, so let's make a note, these are called factors, and these are your zeros, we can go further and write the parabola. All I'm going to do is FOIL or distribute this out, and I can write the parabola. So I've got x squared minus 3x plus x minus 3 equals 0. So I would say this parabola's equation is x squared minus 2x minus 3 equals 0. And all we did was work backwards, starting with the zeros. Let's try the same thing for this graph. Why don't you see if you can start it on your own? Identify the zeros and try to write the two factors. If you're confident, go ahead and write the equation. Pause it, see what you've got. Well, hopefully you're off to a good start. I've got x equals -3 and x equals 4. So I'm saying, what are my two factors so that when I tee it up, I would have gotten -3 and 4? Well, I would say x plus 3 and x minus 4. And then if I FOIL that out, the name, or this function, this parabola, should be x squared minus 4x plus 3x minus 12 equals 0. So I'm going to go with x squared minus x minus 12 equals 0. And there you go. We worked backwards to actually write the equation of that parabola. So lastly, we should be able to find the x-intercepts of a parabola pretty easily. So let's just remind ourselves, another word for x-intercept, of course, is 0. So if you were asked to find the x-intercept of 4x squared, y equals 4x squared minus 1, you would basically just be finding the 0. So the question really is, when does that equation equal 0? Well, what type of factoring am I staring at? Notice it's not a GCF, they don't have anything in common, but 4 is a perfect square, x squared and 1 are. So I'm going to say 0 equals 4x plus 1, and its conjugate, keep the first term, change the second, 4x minus 1. Remember, those are called conjugates. Tee it up, and I would say x equals a -1/4 and x equals 1/4. Those would be my x-intercepts or zeros. One final example, if I said y equals 5x squared minus 10x, and I was asking for the x-intercepts, again, which just means zeros, I'm setting my equation equal to 0. So 0 equals 5x squared minus 10x. When I see two terms and they're not perfect squares, I'm going to think of that GCF first. I can pull out a 5x. I'm left with x minus 2. Tee it up. I have two x's, so I'm anticipating two answers. 5x equals 0, divide by 5. 0 divided by anybody is 0. X minus 2 equals 0, so x equals 2. So again, this is telling me that my parabola is crossing the x-axis at 0 and at 2. And it was a positive x squared, I believe, so I know my parabola is going to open upward. Okay, and I know the roots or the zeros. And that's all this is telling us. When we factor, when we solve, when we tee this up, we're actually finding the roots of the parabola, the zeros, the x-intercepts. We are finding those solutions. Well, that does it for us tonight. Have a great night, and we'll get some good practice in.